I said, we know we're on a compressed day. I want to start Chapter 5. Chapter 5 has a lot of good things in it. We've talked in this class, and we've talked about this in stats also, is the amount of data that we are generating on a daily basis is unheard of. It is unlike anything that has ever happened in the existence of humanity. Okay, last 2 years, more data has been generated than ever in humanity since the start of humanity. So there's a lot of data. So we need to talk about, remember, hardware, software, data, procedures, people. We're going to talk about that middle thing. We just talked about hardware, software. Now we're going to move on to data. And when we talk about data, we need to talk about something called databases. So let us first define what is a database. What is a database? So you guys tell me, what is a database? Come on. Do you have any databases? Aaron, go ahead.
It's like big storage thing that you can have databases for. It's almost like it could be an online encyclopedia would be an example.
Okay, so a couple things like you said, storage, right? It is, a kind of a storage facility. Like there's even things called data warehouses, right? Warehouses store physical items. There are things called data warehouses which store a bunch of data, right? All the data for an organization. We'll talk about data warehouses later. So give me some other words. Maybe you don't have to give me a full definition, but storage, definitely a good one. What else? What else? How? Stored how? Go ahead.
Digitally.
Okay, good. Very good. Digitally or electronically. And when we think about databases or storing things, there's ways to store things. Like the way my things are stored in my garage are pretty haphazard. Like if I can fit things in, I'm happy, right? The bikes go in, the snow blower, there's no room for my car, whatever. We throw those things in there. Now, I could be, though, that I set up little areas in my garage, like this is where the bikes go, and there's a hanger for the bikes, and here's where the garbage cans go, and here's where the paint cans go. Databases typically have a defined structure, okay? And usually it's a predefined structure, meaning someone has intuitively thought about what's going to go where, like what we're going to store, how we're going to store it, how are we going to represent gender? Is it going to be, MF or male, female, or is it going to be male, female spelled out? Are we going to have, for the birth year, we're going to have 4 digits, we're going to have 2 digits? For address, are we going to have 2 address lines or 3 address lines? How long should we make the last name field, right? So all those things are a defined structure, okay? Now, a couple other things that you may or may not be aware of. If I asked you to store information about students in this class, about student grades in this class, and we want to predefine that structure, okay, what would that look like? Give me some things that would be part of that structure. What would be things that would be part of it? If I wanted to store information about students, and let's say student grades, what would that look like in this class? What one thing would I need to store? Elena, give me one thing I need to store. Okay, so names. Yeah, let's start there, right? Let's start with name, right? Let's start with name. All right. So we would have a field, and we're going to talk about this in a bit, but we would have a field called name, and it would be, student 1, student 2, the whole way down to the 25 students we have in here. What else would we need to store? So their name, what else? What other information we want to store? Student grades, what else? What else do I need? Come on, GPA. All right, I don't need your GPA, but we could do it, right? We can put GPA. Like, we could have 4.0, 2.5. Okay, all very well and good. But I'm concerned with grades in my class, not overall grades. All right, so very good. So everyone would have, if you think about it, exam 1, and then there's their score, right? Exam 2, and then there's their score. Maybe things like absences, there's absences, okay? All those things. Now, that structure that we just, is a two-dimensional structure. This is called a list type structure. Okay, it's a list. Basically, it's the same thing you could create on a piece of paper, right? You could put name, you could put, their GPA, exam 1, exam 2, exam 3. You could store all that information on a list structure. And for a lot of things, that's all we need, right? A list structure is fine. Why make it more difficult than it needs to be? But let's say I want to store information about students in my class, but I also want to store information about, like your participation in the class. So maybe I want to store information about every email you send me during this class. Anytime you stop by my office, I want to capture that. Anytime you participate in class, I'm going to capture that. I'm going to store all that information. So how would I do that? How would I do that? So this is pretty easy, right? That's easy. So how would I do that? Like, let's say I want to store information about every office visit you make during the semester. Tally system. Like every time they came in. I want more information than, he came by. I want to know he came by on this date, and we talked about this. Maybe some notes about our meeting. So what would that look like? Chelsea? I'm sorry, Chelsea, would you want to put that as more fields in this? Okay, I kind of forced you to say yes, I know, but why I wanted to force you to say yes is, okay, think about that. That's not quite the right answer, and here's why. So, I need a field that says, all right, office visit 1. Okay, and then I would say, here's the date of that office visit. So date, maybe the notes, okay, for office visit 1, and the notes that go along with that. But say Chelsea comes and visits me 5 times during the semester, right? What would I also need? I would need what? I would need a field for office visit 2, an office visit date, an office visit 2 notes, an office visit date 3, an office visit notes 3. Okay, so think about that. Now, the problem with that is she came and visited me 5 times during the semester, and maybe Marcus doesn't care for me, my deal, so he never comes and visits me. So I have, for Marcus, who's student 2, I have all these blank fields, right? That's not very good, right? And if you think about it, I don't need all that information. That's kind of a separate thing, right? Office visits are kind of separate than grades. So what we're getting at here is a list structure works good if we're storing information about like one theme or one concept, like student grades. But when we start to add multiple themes, like we want to understand student grades, but we also want to understand office visits, and we want to understand emails. We need to expand this structure, and that's where the concept of databases comes in. Okay, so a couple things, and we're going to go a little bit further with this. But if we have a single theme, we can store in a spreadsheet, a list structure, right? Just two-dimensional, very good. But if we have multiple themes, we need to use a database. Okay? And I'm not sure you know how that comes together yet, but that's what I want to teach you. So if we want to keep track of multiple things, that's when we need a database. When we're keeping track of grades, office visits, email correspondence, that's multiple themes we're storing about the student marks. Okay, so we need a database. So let's talk about the structure of a database. Okay, let's start talking about the structure of a database, and there's a hierarchy to it. So in a database, the highest level is the database itself. And a database is made up of what we call tables. Tables are two-dimensional lists. This would be a table. Okay, this is a table. A table is a two-dimensional list like this. student number, student name, homework 1, homework 2, midterm. That is a table. Okay? Inside of the table, we have rows, sometimes called records. For example, we would have a record on Elena. We would have a record on Maggie. We'd have a record on Alex, right? We'd have one row that was dedicated to JJ, one row dedicated to Marcus. Under each of those rows, we store the same information. Those things are called columns, which makes sense because they're in a column, and sometimes they're referred to as fields. Like in the JJ record, we were storing exam 1, exam 2, homework score, name, right? Those are fields or columns, right? If we go a little bit further, those columns or fields are made of characters. The J in John is a character. And if we even go lower than that, that J is comprised of bytes, and bytes are composed of bits, right? So once again, ones and zeros come together to form bytes, which form characters, which come together to form fields, which come together to fill rows and records, which come together to fill tables. So, a couple things. I know that this isn't going to work. Okay? I know that this structure isn't going to work because I don't want to add, Chelsea comes and visits me 30 times during the semester, I don't want to add 30 different fields, right? Just because one student came to visit me 30 times. Some students visit me 0 times. So I need another structure. So think about that. We're going to have a table, okay? This is called the student grade table. And we can have a separate table called the student office visit table. And what would we want to store in the office visit table? God bless you. What would we store in the office visit table? Go ahead. Okay, so you're very right. We want to store date, time, these are fields we'd want, and maybe a notes, right? So what else do we need to know about that office? Not just the date and time and the notes, but who it was. Okay, so we need to know like who, right? Well, let's say I'm just going to leave it at who. Let's say Chelsea visited me 3 times. So she would have 3 records in that office visit table, right? And if JJ didn't visit me at all, he'd have no records, right? So now it's kind of better, right? I'm not storing all these empty fields, right? I'm only storing data where there is data. Here's the problem, though. I kind of want this to come together, right? I want to know, this is Chelsea over here. I want to know that this is Chelsea over here. I want that to be tied together. So how do we do that? That's what a database really does. It takes tables, 2-dimensional tables, and relates them together. Go ahead, Sarah.
Like in the big one, you have like number of visits and have it connected to the other table.
Okay, so what do you mean number of visits?
So like next to where you have absences, you could have like number of office visits.
Okay.
That tracked in the other tables, like however many times Chelsea's name shows up as how many.
Okay, but how do I know to go that that Chelsea here is related to this Chelsea over here? How do I know it's not, Marcus? What do I need to do to tie them together? Go ahead, sir.
They don't have a student number.
All right.
That tracks it from
Okay. Very good. Here is the key. Okay. Here is the key. With every table in every database, there is something known as the primary key. It is a unique thing that identifies this row uniquely. Usually it's not name. Why is it not name? My college roommate was named Bob Smith, for God's sake. I would change my name. I'd be like Ricardo if my name was Bob Smith. That's too plain, right? There was like 3 Bob Smiths here at the same time as him. Name is not unique. No? So how do we make you unique at St. Francis University? Because name isn't it. What's your unique record ID called primary key? What do they call that? I don't call Gensbar ID. You're right, but what do you guys call it? Your student? You guys call it your student number?
Something like that. Same principle.
All right. Do you know your student number? No. At St. Francis, it's student number, Gensbar ID, whatever. How about for Pennsylvania Department of Transportation or Maryland Department of Transportation? What's your unique identifier there? Well, for your vehicle, it's your license plate number, right? How about for you? What's on your driver's license? Your driver's license ID, right? That's your unique number there. How about according to the federal government, the IRS? What uniquely identifies you? Your Social Security number. Think about it when you have an order with an online company. You have a customer number, and you also have, when you order something, you get a order number. You guys think about that? All those are primary keys, okay? Things that uniquely identify you. So the way this would work is Chelsea would have a student ID, and it might be 123. Let's say that's her ID. So how do we know that this was Chelsea? Well, we would have a student ID here. And if it was Chelsea visiting us, it would be 123 there. And now we know that this record is tied to this record. Now, remember, student ID isn't unique in this table, right? It's not. But we need every row in every table to be unique. So we would need an office visit ID, which could just be a sequential number. Like this is the first visit I got this semester. This is the second. This is the third. This is the fourth. So let's put in Aaron. So Aaron is student 111. We'll put in his information, 3.8. All his exam scores. If Aaron visited me, what would that look like? What would need to go over there to say this was Aaron that visited me? What would go right here? 111. Now this record is tied to this record. Okay? So a couple things. Okay, so a couple things that we're getting here. Okay? Databases are made of tables or files, and then relationships among the tables. And metadata, which I'll talk about in a second. Now, this is what it might look like. This is better than my scribbling up here. But we'd have a student table, right? And every student has a student number, a unique ID, their name, their homework, blah, blah, blah. If this Adam came and visited me, okay, it's visit ID for, how do we know it was Adam? Well, it's tied to his record there, okay? The thing that makes every table unique is called the primary key. So what's the primary key in the email table? Tell me what the primary key is in the email table up here. What's the thing that makes it unique? Go ahead.
Student number.
No. Is that unique? Are there multiple rows with the same student number? Are there? Yes, there are. So what's the thing that makes every row in this table unique? Eric? The message itself? Well, not necessarily, because you come and talk to me about the same thing that maybe Marcus comes and talks to me. Chelsea? Yeah, the email number. So every email I receive gets a unique number, right? That's the only way I can make sure it's unique. In this table, the primary key is obviously what? What makes it unique? Name doesn't make it unique. Homework 1 grade doesn't make it unique. Student number makes it unique. Office visit ID makes it unique. So these are the primary keys. Boom, boom, boom. Now, when we have a field that points back, that creates that relationship. For example, this student number refers back to this student number. This student number refers back to this student number. These are also key fields. We call those types of key fields not primary keys, and this is a good term, we call them foreign keys. Foreign keys point to primary keys, right? They're the things that were related. Let's say my 5th visit is on, I don't know, today from Marie Valdez, okay? My 5th visit is today from Marie Valdez. What would go in here? What would be the next entry if Marie Valdez visits me today about Red Day? What would the next entry look like? What would this be? 5. This would be today's date. This would be Red Day. What would go in here? Point back to Marie. So what this structure does, okay? There might be another table called, I don't know, student demographic table. And maybe that table has the student number in it, and then their address and their phone number. So we could tie anything to that table, right? We could tie anything to that table so that if their address changed, we only have to change it one place. We don't have to change it in every damn table. So this is called, a relational database structure, okay? A relational database structure. And this is not an easy concept. It's a very important concept because it's probably how 90% of the world's information is stored. If you've ever heard of Oracle, you guys ever hear Oracle database? That's all relational. DB2, relational. SQL Server, relational database. Microsoft Access, which we're going to use in class, it's a relational database. This structure, if you understand this structure, you inherently understand all of those methods, right? All of those database management systems. It's called a relational database structure. Now, one thing that I did talk about, we said back here that databases are tables or files plus relationships among the tables and then metadata. We used that term once before. We used metadata once before. What was metadata? What is metadata? Okay, data about data, right? So in a database, one of the other things that we can store, remember it was predefined, okay? Well, we can say, hey, this is the date, and then we can have a description. Hey, this is the date and the time the message is recorded. All that is data about the data itself, right? If we had a gender field here, we could say, hey, it's one character, and the metadata could say M means male, F means female, okay? We could have a major code here, and we could say over here the metadata ACCT means accounting, BIOL means biology. Metadata is data about data. All right, so we have, correct me if I'm wrong, we have 15 minutes left? Is that right? Okay. So I want you guys to help me think about a database that is necessary for this to happen right here. Me, you, teaching a class in a room at St. Francis University. What has to happen for this to come together? I'm talking about the data that has to come together for this to happen. So think about it. We need to store information about multiple themes, multiple things that are here. Give me a theme that we need to store data about. Okay. So very good. There would be, at St. Francis University, a table of classrooms, right, Aaron? There would be. And let's think about that. So there would be a classroom table. And Aaron, what do you think is the primary key of the classroom table? I'm not sure what it is, but I could venture a guess. What do you think makes it unique? Yeah, that's unique, right? So that it's unique. SCOTUS 206, SCOTUS 103. You can't go to two places, right? So that makes it unique. So the room number itself, and it's usually abbreviated, right? It would be like I don't know.
Would it start at building number though? Because you could have like.
Yeah, SCOTUS. 103. SCOTUS identifies the building. 103. So it could be. You're right. It could be a combination key. It could be like this. It could be building and room. And then, that would be what's called a combination key. So these two fields together are the primary key, right? And that happens all the time, right? So that probably is exactly how it is. Schwab 213. Okay? What kind of things would we store about rooms? What do you think the registrar stores about rooms? Go ahead. Yeah, capacity, definitely. Okay? Capacity. I've seen this table. So 35, 24. Some rooms are enabled with like this stuff. I'm talking about like projectors and they call those is it a smart room? So it's like yes, no. I don't know. Any attributes you store about a room. Is it air conditioned? Yes, no. Is it the types of desks that are in there? Like these are called tablet desks, and there's different versions of them. You guys know the ones we got rid of in 206. Those like 4 years old, the real small ones. You guys know what I'm talking about? That was, I can't remember what those were called, but they're tablet desks of some sort. These are like more, I don't know, built for people, not kindergarten. And there's tables, right? So very good. We need to store information about classrooms. What else? What else? What else comes together here? Go ahead, I'm sorry.
Like the times that they're assigned to different people, if they're signed out.
Times that they're signed up. What do you mean?
Like, okay, say you're...
Oh, the classrooms.
Yeah.
Oh, okay. Well, we'll get there. But no, that's good. That comes because of a relationship. It's nothing we really need to store. All we need to store is information about the classroom. But we are going to reserve classrooms, but it's going to be reserved via a relationship. But good thought. But what else? Like, think about the themes we need to store information about here. Yes? Okay, very good. We have information, we'll call it courses. Okay, there is a table at St. Francis called the course table. And what do you think the primary key of the course table is? Course code. Very good. So code like what? Like MIS102, like biology 111, like physics 101. Right? Those are the course codes. What do we store about codes? And you can actually see this information in the course catalog. What do we store about courses? Yes. Well, you're going. Okay, very good. The description, right? The description you see in the course catalog. How many credits it is, right? What else? Maybe the title of the course. There's a title for the course. Prerequisites. Yes? Those are the kind of information we store about the course. Very good. What else needs to come together here? What else needs to come together? Yeah, going too far. So just think about, you're right, it all has to come together. It does, and it's a beautiful thing. But what would you say?
Teachers.
Yeah, teachers, faculty. So there is a faculty table, right? And in that faculty table, we would have a unique ID. I have a faculty ID. So let's say 1, 2, 3, 4 is Miko. And what else do you think we'd need to store about faculty? What's that?
The office.
Yeah, we could do that. What office I'm in. Good. What else? Maybe my rank. Maybe my department. But we would have information about faculty. Yes? Very good. What else? What else? Huh? Students, right. You guys are here, right? So there's a big-ass table of all the students at St. Francis University. So student ID, okay? Like student name, maybe your address, maybe your, I don't know, your major, all those kind of things. There's a lot of fields we store about students, right? There's a lot of fields we store about students, okay. So those 4 things, you're right. Faculty, teaching a course, to students in a place. That has to happen, right? But let's think about the process. I submitted the schedule for the School of Business for the spring to the registrar's office. And what comes out in a few weeks? What comes out in a few weeks? The schedule. But what do we call those? Do you guys know what we call those? Because we don't just we don't offer one section of speech. We offer maybe 5 sections of speech. We offer 7 sections of English 103, right? So what do you know at that point? What do you know about that point? What do we call those? I kind of said the word. What do we call those? What do we call this? It is a offering, right? This is an offering of MIS 102. So the registrar office says, what did you like to offer in the spring 2016 semester? And so we send them a list, and it's called the offering table in the system. And there's an offer ID, which is just a unique number, right? An ID. And I say I would like to offer MIS 102. So MIS 102 goes here. This is definitely the primary key. Okay? What would this tie to? What would MIS tie to? Yeah, this is a foreign key to that primary key. So I don't have to, if I offer 7 sections MIS 102, I don't have to duplicate the course description in 7 places, right? It's only in one place, and I refer to it. What else do I have to tell them about the offering? What else do I have to tell about the offering? Okay, so I would put in faculty ID. And I don't want to store the faculty name and all that. All I do is say, well, Miko's going to teach it, and his number is 1224. Okay, so that is a foreign key to that primary key. What else? What else do I need to say about that offering? Okay, so I have a classroom ID. Okay, so I say SCOTUS 103. And that's a foreign key that ties to that primary key. What else is important about an offering? Because you have to know when the hell to be here. Huh? Time. And what do we call that? What do we call that? Section, right? So we have a section, and this is B. And guess what? There's also a table, a section table. It says B means 9 a.m. to 10 a.m. Monday, Wednesday, Friday, typically, except for red day, right? So, exactly. Okay, so we have an offering. We still don't have the most important component put in here. Okay? We have me teaching a course at a time in a building. Great. Well, that's the very, very boring unless something else happens. What happens after courses are offered? Students enroll in them, right? They do. It's an enrollment table. So there would be an enrollment table. And let's say, okay, student 1, which maybe is, or we have student ID, which is Elena. She enrolls in my offering, which is MIS 102. So it goes 1, 1 there. So this is tying student 1 to this offering. Okay? Let's say Marcus is student 3, and he enrolls in MIS 102. Well, now we have a record of Marcus tied to Marcus's record, and he enrolled in MIS 102. But let's say Elena just doesn't want to take one course. She wants to take another course, right? So maybe she registers, she's student 1. Maybe she registers for offering 2, which happens to be, I don't know, Science 101. You guys hate that class, so I'll put Science 101 there. So this is tied to her, and this is tied to that course, and that's tied to her. So when you enroll, you are, it's called a many-to-many relationship, because I can have, in this class, I have many students, and students like you have many classes you're enrolled in. It's called a many-to-many relationship. So this is how it comes together database-wise, right? If you think about it, that's the structure. All two-dimensional tables tied together in a logical way. When you enroll in a class, all you're really doing is creating a record saying, I would like to be tied to this offering of this course taught by this professor at this time in this classroom. Everything is its own table. Every theme is unique. Press on, my friends. See you Friday. Right. Okay, thanks for letting me know. Yep. You know, when they're hit in stats class, they eat more. Maybe they're hungrier then. I don't know why.
Yeah.